Okay, so in this video we'll talk about hydroelectric power. This is an idea that we have introduced to you already in IGCSE physics, so I assume you have basic understanding of it. So we'll quickly go through the basic of it, and then we'll go into those things that you need to know which you haven't learned in IGCSE. So first of all, the basic working principle of hydroelectric power, as you can see on the screen, is simply by releasing the water from a high position to a lower position, then those potential energy, gravitational potential energy, will be released and transformed into kinetic energy. And probably there's a turbine that got driven by those flowing water. So those kinetic energy of the water transfer as in the kinetic energy of the turbine blade. And since you learn generator already, at least in IGCSE level, then you can then transform those kinetic energy into electrical energy. So very simple idea here. And now we include more about a quantitative view towards the hydroelectric power. So if you look at the textbook here, there's an equation that you can see. And one thing is that if you try to look at the data booklet, under 8.1, you will not be able to find that particular equation. All right, this equation, the first equation is pretty much useless. I mean, you already know it, all right, and you can remember easily. The second one is about the wind power, which is probably the next video. So there's no hydroelectric power equation here. So you are expected to derive it and also understand it as well. So the task that I would like to give it to you right now is, instead of deriving it, I want you to read how they derive it in the textbook, page 324. And again, this is the equation. I want you to tell me and state here what kind of assumptions, so maybe one or more than one assumptions that they make when they try to derive this equation. So pause the video, try to read and write down yourself. We'll go through it together.
A few moments later.
Okay, so let's see how many you can think of. So the first one that you may think of quite intuitively and directly, you may talk about the efficiency of the turbine. That's because none of the turbine in the world will be 100% efficient, of course. But then this may not be a very good assumption for this equation, because people can just say the power that you're referring here is just the possible highest powered, all right, before it get to the turbine. So if you like to take it, if you like to write down, that's fine, but then this is not the main assumption that I will write for sure. The second thing that you may write is other energy lost that could be work done against friction, because if you think about the water going down here, there must be some sort of friction between whatever the slide is and the water, and probably, or if you like to put it down as in the third one, there must be some sort of sound energy loss, because well, obviously you can't flow the water silently, like completely silently. So that must be part of the energy that has been taken away. The most important thing, however, like none of these are actually something that I would like to point it out, because these are the things you can already think of when you are in IGCSE. I guess the most important thing, as in the assumption here, is you are assuming all the water, like imagine every single molecule are at the same height, right? So as in initial height. So in fact, if you think about a group or a stack of water, although it may sound strange to say it because water should not be stacking up, but then yeah, a stack of water, then each of them will have different height. So here we only taking the height as in the height of the ground to, or the turbine up to the ground of the water. So like the picture indicated here, H. So you can see that it would assume all the water is simply on this layer. So this is the assumption here. And these are the assumptions that you need in order to get this equation valid. As for the deriving work, it's very easy. You can just read the textbook or you can just do it by yourself. So for the next part here, as I wrote here, I would redefine the situation to you, and I will try to make it a more realistic model, because the one that the textbook gave you is not good enough, I would say. And also there's another possible model that is more suitable that appear in the past paper also. So that's why I would surely want you to pay attention to this. So apparently, like what I said, the last assumption is quite problematic. So let's make it more realistic. So think about this. If you are now having a certain height of water, so imagine these are all filled up. Okay, so with the depth of water that you have stored for, say, capital letter H, then in this case, how would you derive the total energy? Okay, so it's not power, because power depending on the flow rate also. But then let me just ask you, what is the total amount of energy that you can provide when all this water go down to the turbine? So pause the video, try it out. We'll discuss it together.
2 hours later.
Okay, so the answer is shown on the screen here. It is based on the gravitational potential energy, mgh, but then for the last term, it's not only the small h, right? Of course, the small h is because of the slope, like that is above the turbine, but then because of the height or the depth of the water itself, then I'll add one more term into this, which is a h divided by 2. So you may be wondering, why do we need to divide by 2? And let me explain to you quickly. Think about this, like what I said earlier, each of these water will have their own height. So imagine if you try to cut this layer of water into different portions. So let's say you cut it off by 10 portions. So you have 10, 9, 8, 7, 6, 5, 4, 3, 2, okay, not enough space, 1. That many stack of water, there's no 0, right? So 1 to 10, only 10 portion. So what you can do is you can imagine they each, so like each layer, then each of them will have a different amount of gravitational potential energy because they are of different height, simply. But then what you can do is you can kind of take the average. So one way of thinking is think about the center of mass, simply. Okay. The other approach that you can think of is you can kind of do the matching. So you can match 10 with 1. That gives you 11 in total. 9 plus 2, that also gives you 11. 8 plus 3, and so on. All right, 7 and 4, 6 and 5. Then you can kind of get the average out of it. A bit similar to if you heard about how Gauss, the very famous mathematician, when he was a primary student, his math teacher was very lazy, that he didn't want to teach anything. So that day his teacher just wrote on the whiteboard that, I want you guys to calculate 1 plus 2 plus 3 plus 4 all the way up to 100. And of course, I mean, what that teacher is expecting is, since they are primary students, so they will just do it manually. As in, you do 1 plus 2, and then do, apparently that's 3, so 3 plus 3, that is 6, 6 plus 4, and so on. But then Gao was smart enough to observe a pattern, that is, you can actually match 1 and 100, 2 and 99. So then all these combinations will give you 101. And then you can just have to count how many items are there and multiply them. Alright, so this is a similar idea to that story, very interesting story. And that is why you need to take account to the height, the depth of the water dam as well. And that's why I said this will be a more realistic model. And I think this is something that you could also think about as well. That is, in science, all the things that we talk about, all the formulas that we try to create are models. All right, whether or not the models are having any discrepancy from the reality would show the effectiveness, or whether or not these formulas are practical. So you may create some sort of model that kind of predict a certain situation, but probably only one specific situation. So in that case, your model is pretty useless, because whenever we want to build a model, we want to make it practical and then general as well, which you can handle different things. This is what we want to do as a physicist. We want to look for general pattern. So by the time when we try to improve study physics, not only explore some new phenomena or like really exciting thing, but also we try to refine what we understand and try to make as accurate observation and as accurate description using mathematics as possible. Okay, enough TOK. Let's talk about the next thing, pump storage system. So this is a new thing for sure. You haven't learned this in IGCSE. So the basic idea of this is, on top of the hydroelectric pump or powered, you will have a pump that allows you to pump the water back up. So at the first place, you may think that, hey, why do we even bother to do this? Isn't that stupid? You want to get energy from it, right? So if you pump the water back up, you need to pay the energy to get the water back up. So who would want to do that? So the answer is because there are peak season, or peak hours, I should say, not season, but peak hours and off-peak hours throughout the day. So there are times where you may need to have more energy, as you can see from the chart here. There are times where you need more energy or less energy. But if you think about in terms of a city, more from an urban planning situation, then for the power plants that you're doing, like for burning coal or whatsoever, you don't want to keep controlling the speed of burning the coal, right? Because it's pretty hard to adjust. So one way of doing it is we can store those excessive energy, because think about, if people are not using that much energy, those energy you try to generate in the power plants will be wasted. So those energy, in fact, if you can store it and hopefully release it again during the peak hour, then you can have a more efficient plant for your city. So that's why we have such a thing called the pump storage system. Here is a very good video from Practical Engineering. I'll put a link in the description below. I would encourage you to go and check it out. Okay, so going back to page 5, there is a question talking about a statement made by a student, or a hypothetical student. So in his or her statement, there probably is something wrong with it. So try to get some time, pause the video, read the statement, and try to explain what's wrong with that. Yeah, pause the video, we'll talk about it.
A few moments later.
Okay, so this question shouldn't be hard for you. The basic idea that is to go against with his or her statement is simply conservation of energy, right? Because when you try to get the energy from the potential energy, say you have 100 joule or 100 arbitrary unit, when you get the water down, then you probably only get like maybe 60% only, right? So you can't use those energy to pump it back, because when you try to pump using this energy to pump it back, you can only pump at most pump it back to 60, and then if you do this process again, maybe you only get well, assuming the efficiency is like 60%, then you only get 36 arbitrary unit. And again, if you put this back again, the whole process, you just get less and less energy. So the whole idea is simply not practical. Okay, so it's like people who want to build the perpetual motion, which you should have heard of in IGCSE. So yeah, I think this is a simple idea. More importantly, I would like you to do some research right now. So maybe try to spend 1 or 2 minutes to go on Google and try to see if there is any system that is similar to pump storage system. So that is to say, store the energy during the peak hours and maybe discharge them during the long peak hour. So other than using water, what else can you use? From my own answer, of course I do have my own answer. I have 2 solutions. So see if you can find both of them.
One eternity later.
So the first one, surprisingly, is actually from a very famous company, Tesla. Elon Musk, you are very visionary. So what it does is simply think about those, Tesla electric car. So every single electric car is now a walking battery, imagine. So during the daytime, what the city usually do is they require more energy, right, more electrical energy. So the plan is people can get their car to help as a power station to give out energy to support for the peak hour. And during the night, when it is off-peak powers, then their car can take up those excessive energy and put it as a storage. Of course, this should be not affecting any usual daily operation of the car itself. Economically, of course, I don't know whether this has been running already, but then economically, how people would encourage the driver to do this is by, of course, using very direct financial incentive that is basically giving them money. The drawback, because the drawback is to the driver is then your battery, the lithium battery, go through cycles of charging and recharging, and I'm sure all of you know for your phone as well, if you keep charging and discharging, your battery lifespan will get shorter. So that is the drawback. So maybe if you want to get some kind of subsidies money, you may want to go for that, and that helped to solve the issue. Even they put up this on their Tesla website as well. It's called a PowerPack. Alright, and it's something that you can do to do something called peak shaving. So like basically like what we do for pump storage scheme. So this is the first approach that people are now planning to do. The second approach that I found is completely mind-blowing. Alright, the first time I see it, it's just literally blown my mind. So how people can use it is using concrete. Okay, so the reason is simply just heavy, like it has a great mass. So take a look here. Similar to the pump storage scheme about using the water, they do the same thing simply. So what they do is when there are excessive energy, they simply use a crane to move it up, and then you spend those energy onto that and store it there as gravitational potential energy. When you need those energy, you just take it back down. Okay, so it's pretty compact design, because if you think about like if you want to do a water storage scheme, then you need a big scale, of course, right? And that also affects the nature, blah blah blah. But then for this one, you can only do it within a very small area. Alright, and I don't know whether this can go in a big scale, but then definitely it's a genius idea also. So again, I'll put a link in the description. You can try to take a look if you want to. So I think the lesson that we can learn here is don't be bounded by your imagination. right? Like Albert Einstein said, imagination is more important than knowledge. So you guys are the next generation. You guys may probably be the next future physicists or engineers. So try to think in a more creative way. There's always something that you can do to help the world to make a better place. That's all for the hydroelectric power. If you know there are even other kinds of pump storage system similar to that, let me know in the comment section, and next video we'll talk about wind power.